Dear learners, in this lecture, we will learn about mean, median, and mode. In the previous lectures, we have seen about accuracy and precision and various classifications of errors. Here, we will see when you are having a set of data, you can check whether the data are precise or not. You can also see whether the data has how much degree of precision among themselves. These are the topics that we are going to learn today. We'll look into the topic of mean. It is also called as average, and median and mode. The most widely used measure of central value is called as mean, which is represented by x or x bar. It is also called as arithmetic mean or average. It is obtained by dividing the sum of replicate measurements by the number of measurements in the set. If you have a set of data, say for example, if you are in a lab taking up a reading, if you take up the weight of a substance, repeatedly, twice or thrice or 4 times, you can actually take the average of all these readings. So the average is done by the formula given here. X bar is equal to summation I1 to n xi whole divided by n. See, this is a simple formula. Though the formula may look like complicated one, it simply represents the sum of all the values that you recorded, whole divided by how many times the experiment is repeated. So xi represents the individual values of x, making up the set of n replicate measurements. In this solved problem, we are going to see how to calculate mean. So the results of 6 replicate determinations of iron, of concentration of iron in aqueous samples of a standard solution are given here. There are 6 different replicate of experiment, that is nothing but 6 different readings taken while determining the quantity of iron. So all these values are presented here. So concentration of iron is, during the first recording, it is represented as 19.4 and 19.5, 19.6, 19.8, 20.1, and 20.3. When you want to take the average, you simply need to add all these values together and take the sum of these values and divide it by how many number of readings that you have recorded. In the present case, it is 6 readings. So when you divide it by 6, you get a value 19.78. That is nothing but the mean of the set of data that we are dealing here, which is rounded off as 19.8 ppm of iron. So what do we learn from taking mean? We learn what is the central value of a particular set of data. In other words, when you have multiple readings, we try to find out the central reading by taking the mean of the experiment. What is median? Median is the middle result when a replicate data are arranged in increasing or decreasing order. In all the same set of data that we dealt in the previous case, here we arrange all these readings in increasing or decreasing order. You can see in the table presented here, at the bottom, you can find all these values are already arranged in increasing order: 19.4, 5, 6, 8, 20.1, and 20.3. Since they are arranged in increasing order, we need to look for the central value. If we had 7 set of data, unlike the 6 data sets here, if we had 7 different datas, then we can simply say the fourth reading is the central one. So when you have odd number of data, it is quite easy to find out the median. But when you have even number of data, we need to look for the central pair. In this case, the central pair is represented by these two set of data, which I'm encircling right now, 19.6 and 19.8. So on this side, you have two set of data. On the other side, you have two set of data. That means this is the central set of data. So 19.6 plus 19.8, you take the average, it is going to be 19.7. That is the median of this even set of data, which means you had 6 different data points. So we take the average of the central pair, that is given as 19.7. So 19.7 ppm of iron is the median of this result. What is mode? Mode of a set of number of data is often the number that is repeated many times. It is rarely used in statistics. Here we see test scores of different students. Here we have 9 different students present in this class, and we just arrange it in increasing order or decreasing order, and we look for the data that is repeated many times. In this case, 83, which is represented in a different color, is repeated twice. So we can simply conclude 83 is the mode of the experiment. What if you don't have any number present in a data set that is not repeating twice or more than twice? In that case, mode is not applicable to that data set. So when you're dealing with a data where the data is not repeated twice or more than twice, you can simply conclude mode is not applicable to that set of data. Thank you.